All right, next we're going to look at some word problems. So there's 3 different types of word problems we saw. They each have a little bit different of a structure, and what we're going to focus on is one example of each of those. The main thing though, the setup's the hard part. Once you have these set up, it's very simple to solve because we learned you can just graph and look for where the 2 linear equations intersect. So this is an equation where you're going to have 2 things going on. So it says our friend Wolfric here, if you remember this example, lived in 2 different countries for a total of 14 months. So whenever you read something like that, there's a total of 14 months, that's like saying x plus y equals 14. We're kind of already saying that x is going to represent Portugal months, y is going to represent Brazil months, and we're going to have a total of 14 of them. So that happens sometimes with like ticket sales. We've seen examples where it might say total tickets were 500. And then they'll talk about the price of each ticket, and that would be your next row. So that's what's kind of going on here, but it's not price. In this case, we're talking about words he learned while he lived in these countries. So it says he learned 130 new words per month in Portugal. And since Portugal is representing X in this case, I would write 130X. Then it says he learned an average of 150 new words per month in Brazil. So that would be plus 150Y. And lastly, we have to have total words, and that's 1,920. So this could be solved using the methods we talked about before, elimination or substitution. But the quickest way is probably to go graph these. So we would go graph these and look for the point of intersection. And again, I'd recommend Desmos. It's quicker and easier to use than your graphing calculators in this case, if you have one. So there you go, I typed them in already. And if your Desmos screen's a little crazy looking, if you're zoomed out or zoomed in, you can always hit this home button, the little house right here that you're seeing, and it'll recenter you at 0, 0. I'm looking for where these lines intersect, and simply touching there will help us. So 5, 9. X is 5, Y is 9. Now make sure you know what that stands for. X was Portugal, and Y was Brazil. So they're written in a different order here. You wrote the answer for Y first, so just be careful. You could have set it up where this was Y and X, but we chose not to. So in this case, how many months did he live in Brazil? 9 months. And how many did he live in Portugal? 5 months. All right, so again, the hardest part's the setup. I'm pretty sure we can all type that in and graph. So let's look at 2 different kinds of questions and how we would set those up. So number 4 is probably the easiest system. It'll talk about an amount, and a price, and then a different amount, and a price. So the way that's organized, I would simply do the following. Apples is the first fruit they talk about. I'll call that X. Oranges is the second. I'll call that Y. Now, there's not going to be like a total like X plus Y in the previous example because no one's talking about total fruit. These both involve money. So really, you're just going to write the following. 5X plus 4Y equals 10. And then 5X plus 5Y equals 11. Now again, you could solve by substitution, elimination, if you want to, or you could go graph this on Desmos, which is what we're going to do. So I'm going to close out of here, and here we go. So we're going to change these to 5x plus 4y equals 10. And then down here it was 5x plus 5y equals 11. And again, I don't see the graph. I'm going to hit the home button. It zoomed me in here. Now I'm looking for the lines intersect, and it's at the point 1.2, 1. So x is 1.2, y is 1. And what does that mean? Again, we said that x represents apples and y represents oranges. So apples cost $1.20, while oranges cost $1. Ooh, that's a bad looking 0. There we go. Okay. Now the third type of word problem, and we did other ones throughout class, but the ones that you're going to be responsible for like knowing in this course This last one here is we either had like with the wind and against the wind, like a headwind and tailwind when you were flying, or with the current against the current. These are a little bit more challenging. It helps to be organized with your work, and I'm going to help you do that right now. So the first thing we usually did when we did these was we made a little table. And that table involved knowing the idea that distance equals rate times time. That is a formula you may have learned in the past, and it helps with our organization here. So we organize this into 3 columns, D, R, and T, and we talked about what they say in the problem. It'll say with the current and against the current. All right, so in this case, it's I'm going to write with the current up here and against the current down here. You could have wrote against first. This is just the way my brain thought to write it. And let's write down the information we're given in this problem. So the first thing they tell you is against the current. They say a dolphin swimming against an ocean current traveled 60 miles in 2 hours. 60 miles, 2 hours. Okay? Then with the current, same distance, which helps in these problems, and the time was less, and that makes sense. The current was helping the dolphin along, so it took less time to travel, 60 miles. But we want to know what's the speed specifically of the dolphin and the current independent of one another. Now, what you need to do to find R in this case is imagine this formula. To get R by itself, you would have to divide both sides by T. So rate is equal to the distance divided by the time. So essentially, to find R in these problems, you need to find 60 divided by 1.5 or 60 divided by 2. So R in this case is 60 divided by 1.5. That number comes out to 40. And then in this case, the rate, what's 60 divided by 2? That is 30. So you're not exactly done yet, but that is the first step. Now we can't just go graph it just yet. We need to graph it with after we make one small change. So now that you have done that, that was step 1. Step 2, second, will be to strictly look at the rate in this case. Now, if you think about this, with a current, that means you are adding to your speed. That's like saying the dolphin plus the current equals 40. Whereas against the current would be like saying the dolphin swimming against the current. So minus that equals 30. Now, we usually don't use D and C. We usually use X and Y. So what might help you here is to treat this as X plus Y equals 40 and X minus Y equals 30. So I wrote it with D and C so you'd understand what we were doing. But if it helps, why don't we just imagine this as X plus Y equals 40, X minus Y equals 30. And because I wrote it in that way, X is going to represent dolphin and Y is going to represent current. So if we go and graph that here, this system, the X plus Y and X minus Y, that's the trick with these questions. Anything that's with a current against a current, with the wind against the wind, you basically divide distance and time to get rate in both rows, and then you're always doing X plus Y and X minus Y. That'll always be the next thing you do when you graph it. So let's see what we get. X plus Y equals 40. All right, X plus Y equals 40. And X minus Y equals 30. And let's see what our answer comes out to. Oh, I missed a Y in there. There we go. Hit my home button. I don't see them yet. I'm going to zoom out. There we are. And if we get close, we can see that it is 35 and 5. So X is 35. Y is 5. And that means that the dolphin speed in and of itself was 35 miles per hour, and the current was 5 miles per hour. All right, everyone. So this was the word problems for Unit 4. If you can do these kinds of questions, the ones that are designed in this way, you're in excellent shape.